So for my advanced data science course, for the final assignment, I want to speak about the RAG, the retrieval augmented generation. So myself, Jashwant Gurujala, so I will be speaking about this. So what is the necessity of the RAG? But first, I want to basically speak about it. Let's say like if you have an LLM, it doesn't have the data source of the proprietary data of a company. So this is where the scenario where the RAG comes in. Let's say like if you have like a certain documents that are being used in a development process in a company, or the documentation process for building a certain pipelines or certain software development, if one has to query on it, um, the basic LLM doesn't help for that. Connecting to this RAG process, we can be able to do that. So So in this process, let's say like if we have documents, we will do this process. We will basically use the chunking mechanism to split those documents in a separate chunks, and we will use the embedding model to store into the vector DB. So this is the process of indexing that documents are being converted into vectors and stored in a vector DB of any type, let it be a Facebook AI similarity search or Chroma DB or whatever vector database it is. So if a user query is being used, is being given at the time, it will go to the embedded modeling and it will convert the uh, human text into the embeddings, and it will do the vector search, let it be semantic search or whatever it is, semantic search. It will do go or keyword search. It will go into those vector DB and search for those things, and it will give that context to the LLM so that it will make summarization of it, and it will result as a final query. So we can come through the problem that LLM only knows that the data that is being published on the internet. It doesn't know the proprietary data that is being listed part of the company. Um, so by this method, the retrieval augmented generation, which says that retrieving from a vector database and augmenting, making it necessary to the context window. So coming here, we have to discuss the thing of the context window. Every LLM has a different specific context window. It means only certain number of tokens can be passed through the LLM so that it can understand. If we exceed those context window, it says like context window is exceeded. It couldn't read. So it also solves a problem of the fine tuning. Like you can fine tune the LLM always. So by this method, you can make it cheaper than fine tuning. So we can make it dynamically. You can like do updates instantly. Like if you have a new document coming in your company, you can just like upload it into the server where it's like the pipeline will run and it make chunks and converting into vectors, and it stores in the vector DB. So these are the things. So coming to the key concepts of these RAG, I want to discuss about the embeddings, which I clearly explained earlier as well. So these are like converting text into numerical vectors that capture semantic meaning. So several algorithms are being used to convert the natural language into these embeddings. And I want to want to discuss about the vector database. There are several types of vector databases where we can store the embeddings perfectly. So the examples are Pinecone, Chroma, DB, Facebook AI, Similarity Search, and VV8. The retrieval, if a user gives a query, it will go the similarity search, cosine similarity, or dot product. It does the dot product, and it will search for the mostly related keywords for that specific query, and it will give to the LLM, and the generation will happen, and the result will be presented to the final user. Um, so I have used like I have built like small RAG system for your reference here. So I'm using like OpenAI API key to build this. So these are like basic libraries which we want to import, and later on like for the embeddings and vector store, I am using sentence transformers from Hugging Face and the Chroma DB for the vector storage. So this is a like basic code setup, and I am using like a basic document setup rather than the PDF. I will be trying with the PDF in my final project uploading. And the next step is the text chunking. I explained earlier why text chunks are needed, because the search can't be keyword search can't be made using directly for the words. The text need to be chunked and it needs to be converted into vectors. And This is what like creating embeddings, and these are the popular models. These mini LM L6 version 2 creates 384 dimensions for the embeddings, and these all MPNet based to version 2 for the 768 dimensions, and OpenAI text embedding ADA002. This is for 1536 dimensional. This is for commercial use case especially. So these OpenAI text embedding models are being used in the industry to do perfect embeddings. And the final one is the storing in a vector database. So why we are using a vector database efficiently? Similarity search at scale. If you want to like go on like a high volume of data, there a vector database comes in handy to store the vectors, and that's the code, the boilerplate code I have been added here. This is the implementation of the retrieval process. Let's say if a user gives a query that has to be converted into vectors again, and the matching has to be happened, and retrieval process and augmentation therefore after the generation. And this is the generation with LLM's boilerplate code if you want to go through. Yep. So there are this is the simple rack system which I have given here. So you can build the advanced rank techniques, advanced things. So you can make it as like tool based things that you can embed this into the agentic AI problems. And there are like several other search algorithms. We have used only the semantic search in the beginning. There are other types of search algorithms that is called hybrid search, combining semantic plus keyword search here. So here for that I'm using a BM25 transformer to do that. And so improving retrieval quality. So this can be done by using re-ranking. So let's say if you have like initial retrieval might return relevant but not optimal results. So this re-ranking comes in handy so that it can do uh, specialized re-ranker model, or like return top K after re-ranking. It will store in cache and does that. And you can do the query enhancement techniques as well. User queries are often ambiguous and poorly formulated by the user side, so that we can do the query expansion in the backend. So add related terms to the query they are writing, or multiple perspectives of the query, or hypothetical document embeddings. These three techniques can be used for the query enhancement techniques. And these thing is like RAG. How can we like evaluate how the RAG process is going on, and the optimization of the RAG? We do use this metrics, the precision, recall, and mean reciprocal rank, and normalized discounted. cumulative gain. So these four metrics do help us to understand and evaluate the RAG system. Yeah. So for the like if you want to deploy this rack system for the production considerations and the best practices, we can use catching. The catchy embeddings do not recompute for same text. Let's say if a query is being given by the user earlier and want to retrieve about the same query, it can store in the memory, and the batch processing technique and the index optimization where I have used earlier. And the cost optimization, use smaller embedding models where possible rather than like 15, 36 dimensions. So, so these are common pitfalls and solutions. Sometimes when we are retrieving and augmenting and it's passing on to the LLM, the common pitfalls that we could fall off is context length exceeded. So as I discussed earlier, there is a context window for every algorithm that certain tokens need to be processed that can process. That's the strength of the algorithm. Those number of tokens can only be processed at once. So it's better that the retrieval information is dissected into chunks, or it's better that it's retrieval only a specific number of tokens that it can pass on. Those two techniques comes in handy for to solve this problem, the context length exceeded. And the poor retrieval quality, if we won't do the improving of the chunking strategy, this poor retrieval quality takes place and it causes the problem one again. And there are several times that LLMs generate information not in context. So we can do the citations and implemented fact checking for these hallucinations to be dropped. And sometimes like there is like high latency, so this can be solved by implement caching that I've discussed earlier, storing the uh, previous queries in the memory, so and faster embedding models. And we can like using parallel optimization of vector database index. And so these can be like developed into domain-specific multimodal RAGs and RAG-powered chatbot and evaluation suite further. And we have to consider the AI's like RAG security as well. So you have to make sure that it isn't outsourcing the company or proprietary data. That's another thing we have to think of in scenario of the RAG security. So this rack system is being implemented because of the LLMs couldn't know the proprietary data of a company. So these RAG solutions